Hey, it's Coach Reeves again. Hey, today we're going to simplify rational expressions. Okay, so let me throw some little ground rules out so you can understand this. This plus sign. When you see a plus line, I would like for you to do this. I would like for you to put this in parentheses, okay? Because what you have to understand that a plus or a minus sign is so powerful that it holds that top expression together that you're not allowed to reduce off the edges. You cannot cancel or cross out those X's. There's nothing you can do to reduce or simplify that expression, okay? Same thing here. If I have a minus sign, that's going to hold that expression together. I cannot touch this because that plus sign, that minus sign holds that together. I am not allowed to reduce off the edges. You need to remember that rule. That is so important, okay? But if I had a problem like this, to where that the parentheses matched, all right, if I factored this out and my parentheses matched, then yes, those could cancel, and we could also reduce the 4/6 to a final answer of 2/3. But only if the entire parentheses matches are you going to be able to reduce, okay? So knowing these things, let's do some couple examples, okay? But here's the thing I need you to understand, okay? The denominator cannot equal 0. We're going to talk about this. We're going to say simplify and state the excluded values. The denominator can't equal 0. So the first thing we're going to do is when we do this, we're going to say, I'm going to reduce this first. It's always easier to reduce if you want to do this, okay? Question, can I reduce the 36s? Can those 36s just knock each other out? We just said no, no. But what we can do is we can factor out a greatest common factor. In this case, the number 4 goes into both of those. So I could have 36 over, and you factor out a 4, and that's going to leave me with 2n plus 9. 4 on the outside, and I have 2n plus 9 on the inside. Okay? Now, this portion that has the variable right here, that's what I would set equal to 0. I'm going to determine my excluded values. If we're going to look for the excluded values, you take the portion that has the variable and you set it equal to 0. 2n plus 9 equals 0. Minus 9, 2n equals a negative 9. Divide by 2, I get an answer of n equals a negative 9/2. This is what you come in and you tell me n cannot be that. If n was that value, then you would get a 0 for the denominator. And you can't have the denominator equal 0. That's a no solution situation, okay? So your excluded value is what would cause this to be a 0 in the denominator, okay? Now, as far as simplifying goes, let's look at the problem. We are allowed to reduce these because they're outside of the parentheses. The 36 is outside of parentheses. The 4 is outside of the parentheses. I can reduce that. And we can say that 4 goes into 4 one time, 4 goes into 36 9 times. My simplified version would be 9 over 2n plus 9. Big question. Can you cross out, can you reduce the 9s? No, because this is in parentheses. I am not allowed to reduce those 9s. This is your simplified version, and this is my excluded value. Okay? Let's do another problem. All right, so here we go. I'm going to I'm going to factor. I have a 10 in common. I have a 10 that goes into both of these, and that's going to leave me with x plus 6. over x plus 6. I take my denominator and I set it equal to 0. X plus 6 equals 0. We do this before we reduce. You have to determine your excluded values before you reduce. Okay? So then we go minus 6, x equals a negative 6, and then you tell me no. X cannot equal a negative 6 because that would make my denominator equal to 0. Okay? But now we can reduce, okay? We can simplify. We can treat this, that plus sign holds this together, so we can treat that as x plus 6 over x plus 6. This can cancel, and my final answer in the simplified form would be 10. Okay? Remember what I said, the very first thing I said, that plus or that minus sign is going to hold that piece together, that expression together. So we treat that as one thing, and since they match, we can reduce those. Okay? All right, let's try another problem. Now we have to do a little bit more factoring. Okay? So what we're going to do is we're going to factor this top part, all right, and we're going to factor this into, hopefully, by this point in your Algebra 2 year, you can factor this, okay? But this is going to turn into the signs are different. The x's go up front, and that's a negative 42, okay? And a negative 42, I'm going to try to cheat a little bit, but I'm going to use 6 and 7 because that's a negative. I'm going to subtract to find my combination. And 6 and 7, that's going to have a difference of 1. I need it to be a negative. I need this to be a negative 1. So we need the negative sign to go with the 7. So this is going to be a 7. This is going to be a 6 over, I have to factor this. This one says that my signs are the same. The signs are the same. They're both going to be pluses. We have x times x. We have a positive 24, which means we're going to add to find our combination. And we're going to use 4 and 6. Now, remember what I said. Before you start to reduce, you need to find your excluded values. Okay? So, we're going to take x plus 4 and set it equal to 0. X plus 6 and set it equal to 0. We're going to say minus 4, x cannot equal a negative 4. Minus 6, x cannot equal a negative 6. Okay? Can't have it. Okay? So anyway, we reduce. These are our excluded values. And we will reduce. These match. These two match up. So we can cancel those. Simplified form would be x minus 7 over x plus 4. Got it? Yes, you're going to have to factor now. We will factor a bunch when we do these rationals, okay? I know that doesn't make some of you happy. All right, next problem, okay? So we're going to factor. We have a greatest common factor. In this case, the number 6. The number 6 goes into both of them. That will be 6. That will leave me with 3x plus 4. Over here, 12 goes into 12. 12 goes into 48. 12 goes into 36. I have a common denominator of 12. That's going to leave me with x squared minus 4x plus 3. That's not so hard to factor. That's a little bit easier to do now, okay? Keep your 12, because the 12 is still a factor. But we go to two parentheses. Signs are the same. They're both minuses. I get x times x, and there's only one way to get a 3. It's 1 and 3. So there's my factored form, okay? 12, x minus 1, x minus 3. Well, nothing inside the parentheses matches up. So I can't reduce, I can't cancel anything in the parentheses. But look at my GCFs. I can reduce the 6 and the 12. 6 goes into 6 one time. 6 goes into 12 two times. My fault. Too fast. What did I tell you we had to do? We had to find our excluded values before we reduce. Okay? Slow down. Don't get in a hurry. So we're going to say x minus 1 equals 0. X minus 3 equals 0. Plus 1, x cannot equal 1. Plus 3, x cannot equal 3. Those are our excluded values. Okay, now we can reduce, okay? And so this is gone, so I'm left with 3x plus 4, excuse me, that's not very pretty. 3x plus 4 at the top in the numerator over 2 parentheses x minus 1 parentheses x minus 3. Here's what you need to understand. We will not make you go back and multiply to put those back together. Please do not do that, okay? Leave them in the factored form. Excluded values, simplified form. Please do not go back and multiply those together. Take it easy on yourself, okay? All right, let's try one more. All right, now we get some bigger numbers, okay? At the top, you may not know this, but I'm going to tell you right now that the number 14 goes into all of those, okay? The number 14 will go into all of those. So we're going to say a greatest common factor of 14. That will leave me with x squared plus 6x minus 7. And I can factor that. That's not too bad, okay? That's going to give me 14. Signs are going to be different. The bigger number gets the plus sign. So we're going to say one's plus, one's minus. We're going to say x. We're going to say x. And we're going to look at a 7. Well, there's only one way to get 7, and that's 1 times 7, okay? So we're going to say 1 and 7, because we need it to be a positive 6, okay? Divided by, over here, 3 is not a GCF. 3 doesn't go into everybody. So this means that we're going to have to use either the box method or grouping to factor this. Your choice. But I do know that my parentheses, the signs are going to be the same. They're both going to be pluses. So in the box, 3x squared, this goes in the top left. The plus 7 goes here. We multiply your A and your C term, and I get a positive 21. Since it's positive, then I'm going to add. Okay? All right, so I need to add I need two numbers that'll add up to 22. Okay? 1 times 21. That adds up to 22. Easy enough. So I have a 1x and I have a 21x. What do I have in common? I have an x in common. What do we have in common? We have a 7. Going up, I have a 3 and an x in common. Going up, we don't have anything, so we use the number 1. Okay? So I've got an x plus 7, and I have a 3x plus 1. We need to find our excluded values. Okay? Before you start simplifying, find your excluded values. we're going to come over here and we're going to say x plus 7 equals 0. 3x plus 1 equals 0. We're going to say minus 7, x cannot equal a negative 7. We're going to say minus 1, 3x equals a negative 1. Divide by 3. X cannot equal a negative 1/3. Those are my excluded values. Now, do you see anything that matches up? Yes. The x plus 7s match up. They cancel. I'm looking at 14 parentheses x minus 1 in the numerator. In the denominator, I have 3x plus 1. That is your simplified form. And this is how you simplify rational expressions. Okay? Yes, you have to factor. Okay? Main thing is you need to determine your excluded values before you reduce. Okay? Hey, if you have any questions, just ask us. All right? Show up in the Zoom and talk to us, and we can help you. Good luck.